what we remember from Friday. This is on page 255. 255. A researcher tests the braking distance of several cars. The braking distance from 60 miles per hour to a complete stop on the dry pavement is measured in feet. In other words, you're going 60 miles an hour and you have to step on your brakes. You have to come to a complete stop. How long does that take for your car to stop? 455. 255. 255. The braking distance are normally distributed. We need to know this. We need to know its mean, with a mean of 129 feet and a standard deviation of 5.18 feet. What is the longest braking distance that one of these cars could have and still be in the bottom 1%? Okay, now let's lay this out first. So we're looking at a curve. God bless you. So its mean is 129. God bless. Oh, and I didn't lay this out myself. But let's put this all across. This is 134.18. 139. 6. And 144.54. Then we'll go the other way. Usually I have them written down so it doesn't take me too long to do this, but I didn't. We're on page 255. Okay, now, they want to know the bottom 1% in terms of braking distance. Where would I find the bottom 1%? To the left. Now, this is where I'm going to find my bottom 1%. But here's my issue. I disagree with your book. The bottom 1% says to me, do I want to be in the bottom 1% or do I want to be in the top 1% when it comes to braking?
Top.
I want to be in the top. Do I want to take the shortest distance to stop or the longest distance to stop? If I want to be in the top 1%, that means do I want to take long to stop or short? Short. So now, look at your chart. Tell me where, according to braking distances, the top 1% would be. To the left. Now, the book goes by the bottom 1% and they call it to the left. And if they're talking about the bottom of the graph without any meaning to it, yep, I feel it's here. If they're talking about braking distances, I'm going to be in the bottom of this field. I don't want to take the longest to brake, do I? This is the shortest braking distance. This is the longest braking distance. To me, the bottom of the group is over there. So we're going to do it my way. We're going to say this, and this goes against what we normally say. The bottom of the graph is to the left. But in terms of something like braking distance, where it is better to be shorter braking distance than longer braking distance, I think you have to reverse that thought. So the bottom to me is over here. Is that okay with you if I switch this up? Do you agree or disagree? I need to hear your feelings too.
I agree.
Do you agree?
I just know this is a test question.
I wouldn't put it on a test question because in their old book, they did it this way. They did it the way I'm doing it. When they changed their new book, they changed it. They went to the bottom, which tells me maybe they're just looking at the graph without looking at the numbers.
Yeah.
But then don't tell us the numbers. So to me, this is better to have. this would be my top 1%. And I would certainly want my car to be stopping like this, not like this. If you think about it, 144 feet is a long way before you finally come to a stop, right? You'd want to stop maybe at 113, even 113 feet is kind of long. You know, you see something coming and you got to slam on your brakes. So you want your car to stop. So we're going to judge this by the bottom 1%. It kind of goes against what we say because that is the bottom of the graph, this is the top, but in terms of this application, this is not the place I want to be. I don't want to be at this part, so that's considered to me the bottom. I want to be at the top. So how do I find this cutoff point? Anybody remember how we did this? We need to find this X. I want to find that X value. That's that bottom 1% that I pray I'm never in. So we have a formula that we use to find an X value. We have a mean. We have a standard deviation. We do not have a z-score. That's associated with 1% to the right. So how do I find that z-score that's associated with 1%, this area, to the right? Does that answer it? Anybody remember what we did? We picked up our calculators. We went where? Second, theirs. We went inverse norm. And since I want the area to the right, and the z-score gives me the area to the left, I want to say 1 minus 0.01. I just want the z-score, so I leave it on a standard normal curve. I get my z-score. Now, if I did it the other way, and I just put in the 0.01, because I just want this 0.01, I notice that it is the same number, but it's negative. So I only need that number, right? I know that I'm going to have to be positive. So I know my curve has symmetry. So I know my z-score is 2.33. And all I have to do now is put everything in here. My standard deviation plus my mean. And I will find what X value is there. So I get 141.07. And I really don't want to take that long to break my car, for my car to stop. It's a long time. In terms of yards, that's divide by 3. So what is it?
It's like
45 feet.
yards.
45 yards, that's a half a football field. 45 yards, 50 yards is a half of a football field, right? 45 yards is a long way to stop your car. So I say this is the bottom. It reverses the thought of what we did, but applications cause us to change a little bit. Everybody okay with this one? I'm not going to put this on a test, obviously. I don't want to, confuse you. But I do want you to understand that this happens. Okay? All right. Let's go to a normal one now. I think we did that one. We're going to do this one. We're going to do try 5 together. The length of time employees have worked at a corporation is normally distributed, but they told us this, so I could use my normal curve. Okay, with a mean of 11.2 years and a standard deviation of 2.1 years. In a company cutback, the lowest 10% in seniority are laid off, which always happens. Last in, first to go, right? What is the maximum length of time an employee could have worked but still be laid off? So as CEO of this company, I say lay off the bottom 10%. So now I have to figure out, what does that mean? Where is my cutoff in terms of how many years they have worked? So that's what I'm going through. Not how well did they do, but how many years did they work? So I have a mean. I'm going to spread this out. God bless you. I couldn't do this one either. I'm a slacker. And let's put this on. Now sometimes when you do this, if you only want the left-hand side, then you only have to do this for the left-hand side. I'm doing it for the whole thing just so that you kind of get a feel for it. But if you're only looking at the lower part, do the left-hand side. If you're looking at the upper part, do the right-hand side. I do this on the board so that you kind of get a good feel for this. So here's my range of years worked, okay? I want the lower 10%. So somewhere down here, I want this to be 10%. I want to find that cutoff at 10%. Okay, remember our curve is exaggerated, so those little pieces down there are very small. You figure at like -2 and +2, anything to the left or right of those is about 5%, not even. So 10% is a nice little piece of it. Again, to find me an X value, the cutoff value, I use this formula. I know my mean and I know my standard deviation. I don't know my z-score. Now, is my z-score going to be positive or negative? Negative, which I want because I want it to end up subtracting from 11.2, don't I? Because I'm on the left-hand side of it. So again, I pick up my calculator, and this is the one thing I need you to be able to do on your calculator is inverse norm. Even if you don't like it, get used to this one. I want 10%. I want the area to the left, so I can leave it at 10%. And I'm pasting. There's my z-score. Somewhere over here at the -1.28 is going to be where my cutoff is. So I'm going to come here and I'm going to plug in my -1.28. And I'm going to find my x value. And my x will be 8.512. Now, you have to figure out where to round this. I need to round this so that I stay in that shaded area. This bar right here says 8.512. I need to be in this rounded area. So what should I round this to? Give me one decimal. 8.5 sound good to you? I need to round down because I need to round into this area. If I need to round to the right, I need to round up. Sarah, put your phone away. I need to round up if I'm going to the right. I need to round down if I want it to be in that area. So now as CEO, I'm looking at everybody's employment. Anybody employed 8.5 years or less, I have to lay them off. There's my 10% cutoff mark. And 8.5 years is a lot of years to work to get laid off. But looks like my people have worked a very long time to begin with. My standard deviation is small. My standard deviation is small considering my company. Usually there's a little bit more wiggle room in between where your standard deviation, you vary a little bit more off the mean. This stays very close to the mean. So that's where I find my 10%. Now, for you guys that like the calculator, I'm going to take this a little further. When I go to inverse norm, notice your mean and your standard deviation are 0 and 1. Remember when we did the normal CDF and you were able to put in the mean and the standard deviation? You can also do it here. I'm going to put in my area. I want 10% to the left. My mean is 11.2. My standard deviation is 2.1. And I paste. And I come out with 8.51. The same thing that we came out with underneath here, 8.51. So it bypasses doing this. So you know how you bypass doing your z-scores before? You can bypass doing that formula. Because what you're telling it now is, I want the area to the left, I'll give you my mean, I'll give you my standard deviation, you calculate it and tell me the x value. So the only thing you have to make sure is that you use the exact area. You can't use the area to the right or to the left and use symmetry because it has to pull up the right area. If I was going to the right, I have to say 1 minus my area. If I wanted to know the top 10%, what am I doing? If I wanted to know the top 10%, I would have to say this, parentheses, 1 minus 0.10. I can't use symmetry on this. I can still leave this here, and then it'll give me my top, whoops, I must have done something wrong. Oh, I forgot the parentheses. I gotta use 1 minus that. And now it'll go to my top 10% and say, oh, the top 10% cutoff is 13.9. And round into it. 13.9. It bypasses this. You just have to be careful of where your area is. I know some of you guys like that part. Okay. Do you have any questions? It's been a little while. I want you to do 31, 35, 37, 39, and 40. Okay?